Imagine peering at the vast universe through a tiny keyhole, seeing only a sliver of the wonders that lie beyond. For decades, our view of the cosmos was limited, as if we were trying to glimpse the secrets of creation through a narrow crack in a door. That all changed when the James Webb Space Telescope opened a breathtaking panoramic window for humanity, allowing us to witness the universe in ways we never thought possible. Launched in 2021, after decades of planning and engineering, Webb is far more than just Hubble's successor. It's a revolutionary cosmic time machine. By seeing in infrared, Webb can peer through cosmic dust and gas, unveiling mysteries that were once completely hidden from view. Its massive gold-coated 6.5-meter mirror unfolds like a work of art in the vacuum of space, while a sunshield the size of a tennis court keeps its instruments ultra-cold, protecting them from the sun's heat and allowing for incredibly sensitive observations. This remarkable design lets Webb peer through thick clouds of cosmic dust, capturing the birth of stars and galaxies, and looking back over 13 billion years to the universe's earliest days, almost to the dawn of time itself. Every image Webb sends back is like a postcard from a previously unseen realm, each one challenging and expanding our understanding of the cosmos, and revealing beauty and complexity we never imagined. Webb's discoveries already include the deepest and most detailed infrared images ever captured, showing thousands of galaxies in a single frame, some from when the universe was just a few 100 million years old. It has revealed the atmospheric details of distant exoplanets, detected water vapor and organic molecules, and captured breathtaking images of star nurseries where new suns and planets are being born. Webb is our most powerful tool for answering the biggest questions in science. Where did we come from? How did the universe begin? What is our place in the cosmos? And perhaps most tantalizingly, are we alone? With every observation, Webb brings us closer to understanding the origins of everything we see, and the possibility of life beyond Earth. And now, Webb has spotted something truly extraordinary, an anomaly that could change what we know about our universe. The story begins with a mysterious visitor from beyond our solar system, a cosmic enigma that has captured the imagination of scientists and stargazers alike. Enter 3I/Atlas, a name that signals its interstellar origin. Unlike anything from our solar system, this object was born around another star and flung into the galaxy, wandering for eons before passing through our neighborhood. It's only the third confirmed interstellar visitor after Oumuamua and Borisov. Discovered by Hawaii's Atlas survey, 3I/Atlas is a rare scientific opportunity, a physical sample from another solar system. By analyzing its light, we can compare its chemistry to our own comets and asteroids, asking if our solar system is typical or unique. 3I/Atlas was faint, fast, and fleeting. Scientists raced to study it before it vanished forever. The James Webb Space Telescope was aimed at this cosmic traveler, hoping to reveal its secrets. What Webb found was completely unexpected. This wasn't just another rock, it was a puzzle that would challenge everything we thought we knew. High above Earth, the James Webb Space Telescope turned its powerful gaze toward a mysterious visitor from beyond our solar system, 3I/Atlas. Using its advanced infrared spectrographs, Webb began to break down the faint light streaming from this interstellar object, hoping to uncover its secrets. Astronomers searched the data for familiar comet ingredients, water vapor, carbon dioxide, or organic molecules, expecting to see the usual chemical signatures that mark icy wanderers from the outer reaches of space. But instead, the data revealed something astonishing, a bizarre, luminous plume trailing the object. This was no ordinary tail of dust and gas, it was a jet of hot, glowing material, with a chemical fingerprint that defied every expectation, unlike anything ever seen in a natural comet. The spectrum showed strong, unmistakable spikes of ionized argon and xenon, elements that are extremely rare in comets and which require enormous amounts of energy to be ejected into space in such quantities. The research team double-checked their instruments, scoured the data for errors, and even considered interference from cosmic rays. But the signal was real, persistent, and clearly coming from 3I/Atlas itself. What was even stranger, the plume wasn't chaotic or diffuse like typical comet outgassing. It appeared focused, almost as if it were being directed or controlled by some unknown process. The discovery sent a jolt of excitement through the research team. What began as a routine observation had suddenly become a historic mystery, one that could rewrite our understanding of the cosmos. The highly specific, high-energy plume simply didn't fit any natural explanation. It was as if the object was using a kind of propulsion, or releasing energy in a way never before observed in nature. In an instant, what had seemed like a quiet, unremarkable interstellar rock became a cosmic headline, capturing the imagination of scientists and the public alike. What could possibly create such a powerful, focused signal in the depths of interstellar space? Was it a natural phenomenon or evidence of something far more extraordinary? The answer, if it could be found, might change everything we thought we knew about life and intelligence in the universe. Was this the result of a rare cosmic process, or could it be the first sign of technology beyond Earth, a message, or even a propulsion system from an unknown civilization? The search for answers had begun in earnest. Teams around the world worked late into the night, analyzing every detail, debating every possibility, and preparing for the next round of observations. The implications were staggering. Humanity stood on the edge of a discovery that could reshape our place in the cosmos forever. To grasp the shock, let's talk propulsion exhaust. On Earth, it's the hot gas from rockets or engines, Newton's third law in action. In space, chemical rockets burn fuel, while ion engines use electricity to accelerate noble gases like xenon or argon, producing a steady, efficient thrust. The exhaust's chemical makeup reveals the engine type: water vapor and CO2 for chemical rockets, ionized noble gases for ion engines. Here's the kicker. Webb detected a plume of superheated ionized argon and xenon, just like advanced ion propulsion exhaust. Nature doesn't make comets with engines. Natural outgassing is chaotic, not a focused, high-energy plume of heavy elements. This signature is extraordinary, evidence that demands explanation. Could 3I/Atlas be more than a rock? The data forced scientists to consider the unthinkable. Was this the exhaust of an interstellar engine? Before leaping to aliens, scientists searched for natural explanations. Cometary activity, ice sublimating into gas, was the first suspect. But typical comets release water, Colorado, and CO2, not focused plumes of ionized argon and xenon. Solar heating isn't powerful enough to create such a plume, especially so far from the sun. Maybe a pocket of noble gases burst from inside, or a recent impact vaporized part of the surface. But these scenarios require rare, unlikely conditions and don't explain the sustained, focused plume. Each natural explanation seemed more far-fetched than the last. The evidence pointed away from ordinary comet behavior. The mystery deepened. Was something else at work? As natural explanations for the mysterious object grew increasingly unlikely, a new and thrilling possibility began to emerge: the idea that its origin might not be natural at all, but artificial. The possibility of an artificial origin loomed larger with every unanswered question. What if the strange plume we observed wasn't a comet's tail or a burst of gas, but instead the exhaust of an advanced ion propulsion system, technology far beyond anything we've seen in nature? If that were true, then 3I/Atlas wouldn't just be a wandering rock or a chunk of ice. It would be a piece of technology, perhaps a probe sent from a distant world, a derelict engine drifting through the void, or even a messenger, purposefully launched by another civilization to explore the galaxy, or to make contact. The discovery of such an object would be nothing short of revolutionary. It could finally answer one of humanity's oldest and most profound questions. Are we truly alone in the universe, or is there someone else out there? An interstellar probe would require incredibly robust engineering, a power source capable of lasting for decades or even centuries, and a propulsion system efficient enough to travel between the stars, just like the signature that the Webb telescope detected. In fact, it's the kind of technology that we ourselves dream of building for our own future deep space missions, as we imagine reaching out to other stars. Of course, all of this remains speculation, built on a single tantalizing clue, but sometimes a single clue is enough to change our perspective entirely. It's as if we've stumbled upon a message in a bottle, cast adrift in the cosmic ocean, an artifact that could carry secrets from another world. Even if it turns out not to be a deliberate greeting, its mere existence would be proof that we are not the only ones capable of reaching across the stars. The implications of such a discovery would be profound, shaking the foundations of science, philosophy, and our understanding of our place in the cosmos. It would suggest that the universe might be far more crowded and far more mysterious than we ever dared to imagine. Why does this matter? Whether 3I/Atlas is a natural oddity or an alien artifact, it's a scientific milestone. It's the thrill of the unknown, a result that defies easy explanation. If it's a new natural phenomenon, we'll rewrite our understanding of comets and planetary systems. If it's artificial, it's the greatest discovery in human history. The knowledge that we're not alone would transform our philosophy, art, and sense of self. It would unite humanity in a way nothing else could. This mystery captivates us all, not just scientists. It's a cosmic detective story with the highest stakes. We stand at the edge of the unknown, holding a clue that could change everything. The journey to the answer is as thrilling as the answer itself. Whatever the truth, we're about to learn something incredible. And the world is watching. The search for answers is just beginning. Scientists are racing to observe 3I/Atlas with every telescope available before it slips away forever. Webb will make follow-up observations looking for changes in the plume or new clues. Ground and space telescopes will study it across the spectrum, piecing together the puzzle. Some dream of sending a spacecraft to intercept it, a daunting, high-speed chase across the solar system. Meanwhile, theorists will debate, publish, and model both natural and artificial scenarios. Every idea will be tested against the evidence. The truth will emerge from this global scientific effort. The search is on, and the stakes couldn't be higher. This could be the most exciting scientific quest of our time. We end where we began, under the stars, asking, are we alone? For centuries this was philosophy. Now, it's science. 3I/Atlas offers the most tantalizing clue yet. The universe is vast, with billions of stars and planets. The idea that we're alone seems less likely than ever. If this is an alien artifact, the universe is alive with possibility. Even if it's natural, the search sharpens our tools and our imagination. Every mystery brings us closer to understanding our place in the cosmos. The quest for life beyond Earth is a journey of self-discovery. As we await more news, we're all part of this incredible moment. Thanks to Webb, we're finally beginning to listen to the cosmos.